Good evening. The first half of this video is going to really be the notes that I want to see written into your book. So in this first half of the video, it will be like all of the other videos you've watched so far. You'll just copy down what's on the screen, playing it back to yourself as you need to make sure that you get it all down accurately. The second half of the video will be me demonstrating what you'll need to do using the actual glassware. And again, you can watch that part of the video as many times as you need to so that you come into the room confident that you know what it is you'll need to do in the lab. So let's begin with the notes. The reaction that you will be performing is a very famous reaction in chemistry called the iodine clock. The aim or the purpose of this investigation is to determine if there is a relationship between temperature and the time it takes for two chemicals to react. It's important that you be able to perform this investigation safely. First of all, the most significant risk is probably broken glassware, which of course could cut your skin. So as always, you will report any and all breakages directly to me without touching them or trying to clean them up on your own. The solutions that you're working with will irritate the eyes quite a lot, as well as the skin. So first and most importantly, you must wear safety glasses at all times. I will also ask you to wear an apron. That will help to protect your clothes. If your skin, or especially your eyes, become exposed to a spill, you must start rinsing immediately with water, lots and lots of it, and tell me what's happened straight away. Finally, these solutions are toxic, so hopefully it goes without saying that you will never ever drink solutions in a chemistry lab. Secondly, it's important that you not pour the solutions down the sink because they're toxic to fish. Instead, I will give you special instructions for how to dispose of the solutions when you're finished. The method or procedure is quite involved. It involves 9 or 10 steps, so listen carefully and make sure that you get it all written down. Number 1, use a permanent marker to mark 5 test tubes with the letter A. Mark 5 other test tubes with the letter B. Do this up near the very top of the test tube, near the mouth. Then, step number 2, collect 10 milliliters of solution A and 10 milliliters of solution B. When I hand them to you, they'll be quite cold. They've just come out of the fridge, so they will be about 5 degrees Celsius. Now, divide that 10 milliliters of solution A into 5 test tubes that you labeled A. So that means that each of the test tubes labeled A will contain 2 milliliters of solution A. Do the same with solution B. I will give you 10 milliliters of it. Divide it evenly between each of the test tubes that you have marked B. Next, choose just one test tube that is marked A, and also one test tube that is marked B. Mix them together. Just pour one into the other. It's that simple. Use your stopwatch to measure the time it takes for the reaction to occur, and record this time in your table. You will know when the reaction has occurred. I don't want to spoil the surprise, but trust me, when something has happened, you will know. Step number 6, place your remaining 8 test tubes in a beaker that is partly filled with water. Insert a thermometer into one of the test tubes, any one, it doesn't matter which. Then begin warming this beaker with its water and its test tubes inside on a hot plate, but slowly. Keep an eye on that thermometer. When it says 10 degrees Celsius, combine one of the test tubes that's labeled A with one of the test tubes that's labeled B And once again, use the stopwatch to measure how long it takes for the reaction to occur. Finally, repeat that last step, step number 8, as soon as the thermometer says 15 degrees Celsius. Do it again when the thermometer says 20, and again when the thermometer says 25. By that time, you will have no test tubes left. Before you can begin this practical, you're going to need to have a table in which to record your results. That's on the screen in front of you now. So also make sure that you carefully copy down this table before you begin. Next, I'll demonstrate to you all of that method again, this time actually showing you the glassware I mean for you to use.
All right. When you come into the lab to begin your iodine clock experiment, you will need to collect from me 2 measuring cylinders that both contain solutions in them. One will be labeled A, like that, and it will have a solution in it that looks like water, but this is not water, and so of course no one's going to try to drink any of these solutions ever at any time. The other measuring cylinder will also be clear and colorless like water, but will be labeled B, and you need one of each of these. Your first task is to collect 10 test tubes. Label your test tubes using a permanent marker. Label 5 of your test tubes A, up at the top, right up at the mouth, just like that. Label 5 of your test tubes B, again, right at the top, just like that. So, next step is to carefully measure 2 milliliters of solution A from the measuring cylinder into each of the 5 test tubes that are labeled A. So solution A goes into test tubes A, 2 milliliters at a time. To help you do that, you might like to use one of these little plastic droppers. This is a pipette, a little plastic eyedropper, basically. So you can squirt that into your test tube A, into your measuring cylinder A, suck up some of the solution, and then squirt it into the test tube that is labeled A. Do the same thing for B. Now, your next step is to obtain one of your A test tubes, one of your B test tubes, and pour them together, just one into the other. If you'd like to transfer them back and forth once or twice, just to mix them thoroughly, that's fine. But from the moment they contact each other, you have to start your stopwatch. Okay, so the minute you combine them, start your stopwatch. Now record how long it takes before you see something happen. You'll know it when you see it. Next, take your other 8 test tubes. 4 of them are A, 4 of them are B. Stick a thermometer into any one of them, doesn't matter which one, into the test tube itself, and place them in a beaker full of water, just like this one. So if you have a look, you'll be able to see there are 8 test tubes in this beaker, and they all have a little bit of those solutions in them. The beaker has water in it, just from the tap. Now, all of those go onto a hot plate, and you need to watch them very carefully. When the thermometer says 10 degrees Celsius, choose 1A and 1B. So that's one of them is labeled A, one of them is labeled B, and mix them just like before. Then you can put them away after you've seen them react, after you've recorded how long it takes them to react. Leave these to heat in the meantime, And every 5 degrees Celsius, you combine an A and a B test tube. So you're combining A and B test tubes at 5 degrees Celsius, that's the very first one, then at 10, at 15, at 20, and at 25. Each time you combine the solutions, you record using a stopwatch, there's one on your iPads if you like, how long it takes before you see a chemical reaction. That's all there is to it.